All right, so last time we were here, we began our look at a simple random experiment, right? You were each given a question to answer, and that question was completely your opinion. But we tried to alter your opinion a little bit by giving you, what are they called? An anchor, exactly. So we gave you some information. Was that information true? One of them wasn't, but the 30 was pretty close, right? The population of Venezuela is about 31 or so, 32, 28, depending on what source you're looking at. Yeah.
People leaving Venezuela.
So.
This is political turmoil, guys.
There you go. Okay. Well, that wasn't part of it. So what I asked you to do afterwards was we collected the data and talked about the population estimates that were based on just your guesses. And then you were supposed to put that into the NZ grapher and make some box and whisker plots and dot plots as well. How'd that go?
Not well.
Not well?
Because I forgot how to use it. But then Lara told me how to use it.
Okay.
Because she's a good friend.
That's an excellent thing. You have a good friend. So how'd they go? Did you notice any similarities between the two?
They both have the same sort of lower quartile and medians area.
So the statistical data for the lower quartile and the medians were about the same?
Yes.
Okay.
The upper end of the box was a bit more.
Was a bit higher.
Yeah.
Did you do the randomization part? Okay. All right. Did anyone do the randomization on the New Zealand grapher? NZ grapher? No? Okay. Well, we want to. Remember, you were supposed to go to the randomization button, hit that, and then the computer will run that experiment over 1,000 times so that you could get the mean. Because we need to understand. So we can compare the means and get the probability. Because we need to understand that sometimes it really doesn't matter what happens. The probability of getting the same thing happening over and over is so large that the experiment is statistically inaccurate, right? So the probability of me surveying a female student in this school? Yeah, there you go, right? So you see that sometimes if you pick the wrong population or if you're doing some experiment where the probability is very high that you're going to get one particular outcome, then it's not going to stay statistically important to you. So we'll talk about that as well. And the cutoff point for that is a probability above 10%. Does 10% seem very high to you? No, 10% is not that big of a number, right? But 10% is the cutoff point. So any probability anytime that you get a probability of greater than 10%, then there's a good chance that it wouldn't matter what your experiment showed, right? Because the probability that they're going to come out to be the same is very high. Okay? So keep that in mind as we're working with our experiments and our data. Okay? Today what we're going to do is we're going to go to OneNote and we're going to look at some more of the information about the type of data and how to build this experiment, right? You're going to be building your own experiment, collecting your own data, asking questions about it, etc. So we want you to be familiar with what's going to be expected of you. So if you could go to your OneNote so that we could all be doing the same thing. Yeah, it's a new one.
Wait a minute. I haven't been invited to it.
Oh, you haven't been. What I want to do is I want to look first at some of the criteria for designing an experiment. We're going to spend some time designing the experiment, and then, of course, you're going to be assessed on this experiment. So I've printed out the assessment checklist. It's also on your OneNote, but it's pretty important, so I decided to give you a copy of it as well. So could I get a volunteer? Anybody, please? You know, I never have that problem with my 7th and 8th graders. They're always volunteering. There you are. Thank you so much. Just give one everybody if you will. Thank you. And so we want to talk a little bit about this paper that I'm giving you.
do the randomization and use it there? Is it the one that says it is?
This checklist that you've gotten is the checklist that will be used to evaluate and assess your project. So you need to be using it to assess your own project as you go, to make sure that you're getting all of the things that you need in your experiment. So let's just talk about a few of them. Some of them are very self-explanatory, I hope. For example, it should always start with a title, right? If you don't have a title, then you don't know what it is you're measuring, what your report is about. Then you're going to express your problem. So you're going to get a possible background of why you're looking at this. If you're looking at something for some particular reason, I always wanted to know something. Or I want to be a blank when I grow up, so I want to know some facts about this. Something that gives you a little bit of background of why you're looking into it. I chose this experiment because my teacher told me it would be the easiest one to do. Whatever. Something. Right? Hopefully that's not the one you'll choose, because I'm not going to tell you one of the easiest. Then you also want to have a statement that says, I wonder. Okay? And you want to have the word causes in it. It's going to be very important. Right? If they're going to take the time to type that into the checklist, then what do you think happens to an experiment that comes back without it?
You don't get good marks.
There you go. Can you say in? Okay. And then you're going to give a hypothesis or a prediction of what you think will happen. So we want to have choose something so that you can give some kind of idea of what you think will happen before you run the experiment. Right? Now, that doesn't mean you have to pick something where you absolutely know the outcome. That's not what we're looking at here. But just give an idea of what you think is going to happen. Then you're going to describe the experiment. You're going to have a discussion about what happened during the experiment. Stop it. I'm really not liking that. Why is that coming up? Maybe it'll go away. Oh, well, let's have the whole thing go away. There we go. All right. So a discussion about what happened during the experiment and any issues that arose. And this is very important. There are lots of things that can happen to you when you're performing these experiments, and you need to make sure that you document them, right? I could bring that survey in here, and you could all just say, I don't feel like filling out a survey today, right? Do you think that might happen if you ask somebody to fill out a survey? Certainly. Or you could give it to a group of your friends, and they think it's silly, so they're going to give you goofy answers, right? Any of these things can happen to you while you're performing your experiment. And so you need to address those issues. If your data is completely out there, doesn't make any sense, then those issues could explain why that happened, right? Then finally, you're going to give your data and make sure that you do the box and whisker graph as well as the summary statistics, mean, median, mode, etc. And plus, you need to do the randomization graph so that you can see if your results hold true over the course of lots of results. Because are you going to have time to talk to 1,000 people? Probably not, right? But so we'll do a continue to randomize those results and see if we can't get the same results as you got in your small survey. For analysis, you need to describe the key features of the graph, right? Median, maximums, minimums, first quartiles, third quartiles, right? Statement of what test you're going to carry out. Display the results of the test, give a summary of the results, and give a formal inference statement. A formal inference statement, and we'll talk about what that means as we go. And finally, draw a conclusion that has to be linked back to the original problem. Don't make some conclusion about, I think my study was flawed, right? Don't do that. Go back to the original. My data shows that people definitely do prefer oranges to be orange, right? I don't know. You pick what you want to. And then finally, you need to include your raw data as an appendix. don't just give a summary of the data. Give us a copy. If you did surveys, then give us a copy of those results so that we can see what it was that you did, right, and how it was done. Pretty straightforward. Okay. So last time in year 12, if those of you who did this, you just had to look at surveys and studies that were already done. So you've seen all of these things done, but this time you're going to start from the beginning and do it yourself. Okay? Hold on. So you were asking about the times. Forgot that Apple Pencil doesn't work. So the time frame for your internal, you're going to practice in week 8, and then it'll begin the last 2 lessons of term 3. It'll be due in term 4. Dates, I have no idea. I don't even know when term 4 begins. So I'm too new. Okay? Good question, though. All right. Okay, so what we're going to do is we're going to look at, so what you see on the screen is a student, and this one got low excellence. So if you look, it's clearly stated, investigating the possible bias in questionnaires from using anchors. So she wanted to look at the effect of anchors, right? And that's exactly what we did. We said the population was 60 million or 30 million to see what would happen, and then talked about why it would be important, right, to collect data, and then to see if that would influence the answers, etc. We wanted to see if you can give information in the questionnaire that would trick people to give a certain answer. And you didn't fall for it as much as most, but your answers were pretty steady, right? Okay. So then she talks a little bit about what she did, researching the different types of questionnaire bias, and founding examples of how people have used anchoring. So here she's just looking at all the different ways and doing an investigation of what it is she's studying, etc. Okay, I'm not going to go through the whole thing because I know you can read. Then she's talking about what she did, right? So here's the what. She's done the why. And now she's thinking about doing what she did. Used single blinding, and the participants didn't know which treatment they were getting. Just exactly what we did to you, right? And did the survey. Then she talks about the response variables and the treatment variables. You need to have this language in your assessment as you go, right? So one group had the anchor was 60 million, the other group was 30 million. The population of Venezuela is around 29 million at the time of this was written.
So the definitions remain with the last list was pretty much all required to be mentioned at some point.
Most of those things, yeah. Not every single one of them, but most of those things. And we'll go through as we learn how to do this, and you're going to have some reading and the chance to be able to write pieces of each of these things in from your exercises. And then she talked about how she randomized it, right? So she didn't just give this table 30, that table 60. She shuffled them all up, and so everybody had an equal chance of getting 30 or 60, right? So how she separated the samples and how she made the questionnaires. Talks about some factors, right? What are some of the factors that might have changed your opinions? What if you were from Venezuela? You might have an idea of what the population is, right? Or if you've traveled there, or if you are just fascinated by geography and you happen to know. Yeah? So lots of those things that you are. And I love that one, whether people would take the survey seriously and not give silly answers. And I'm sure none of you would ever do that, but it does happen. Okay? And you might have studied some of this before and already know about anchor bias. We already know that if someone gives you an idea that you're more likely to continue that. So you see all the different things. And look, she did several of those. Then she talks about the re-randomization process, what she did, and the statistics behind that, and finally drew her conclusions. Okay? she got low merit. Can anybody tell me, from looking at this report, there's one huge thing missing? Everything was beautifully done. It was well written. The descriptions are good. What did she forget to do? Yeah, where's the graph? Where are the pictures of the data? Right? Okay? So you see that you can still do a pretty good job without everything, right? But she did all the hard work beautifully and then left off the easy thing that the computer does, right? So make sure that you don't leave anything off when these are all complete. And that is one reason why the checklist is so important, so you can go through. And again, what we're going to do in the lesson part of this, because frankly, y'all are going to be doing most of the work when you're dealing with your experiments, right? What we're going to be doing in the lesson part of this is just going through, going to give you some small examples, and you're going to write out statements that go with them. So you're going to see how to write all of this out as you go. Okay? How does it look? All right. Then, so for your homework, what you're going to be doing is you're going to be doing some readings out of your booklet. You're going to read pages 12 through 19, okay? And then you're going to answer questions 5 through 14. So do those readings and do the questions, and we'll look at them real quickly together just so that you can see what the questions look like. So in this section, what they're talking about is how to design the questions you're going to be asking, talking about the possible investigative questions. So if you just look on page 15, for example, just look at like number 6. It says, what affects a person's accuracy at estimating the passage of time? Right? So there's your study question, right? Participants will be divided into 2 groups, a control and a treatment, and asked to estimate a time interval of between 30 and 45 seconds. So they've given you the idea. They know you know what question we want to know. How well can you tell how much time has gone by? And they're going to be given given 2 groups, a control and a treatment group, and asked to estimate the time interval of between 30 and 45 seconds. So they're just going to start a timer, and you're going to say, when you think it's been between 30 and 45 seconds, you're going to say stop, right? Okay? So we want to know. So we're going to write a possible investigative question for the following, and it should include the explanatory variable, the response variable, and the population the results are applicable to. Also include a predicted outcome. Okay? So they're just going to give you these statements, and then you're going to answer those questions and write a short paragraph about what each of those pieces would be. Okay? And all the information is there for you. All right.